Okay, that's good. Okay, so there's also other there are two presentations from last semester on my YouTube channel, so you can go there and check that out. It probably I probably did a better job then than now. So if you don't understand what I'm talking about now, it's fine. Just ask me a question and then just go on and watch the previous one. So so this is a slide that I remember because I used people didn't really read the instruction and read all the provided resources, and they just straight up went to my office hour and asked questions without actually watching anything. So I just want to remind everyone to read the PA instruction along with all the slides and watch the videos and tutorial posted on campus. They're very helpful, and then you can come in to me and others on Teams to ask even more questions. But you should formulate new questions instead of just repeating the old one that is already answered. But let's talk about the shell. So the goal is pretty simple. We just want to mimic the shell been using the Linux for a year, using exec and fork extensively. So you know, in PA1 you did it once. You just do fork and exec once. The child server is nothing really. It's just gonna just do that. So now and then we're gonna talk about unnamed pipes. We're not gonna, with previous one you talk about named pipe with FIFO. So you have the name of the pipe and everything inside of your PA1 directory. But in this case, there's no name or anything like that. You just pass it within function and it passes through memory, everything like that. There's no name. And then we'll try to mimic many features, but our shell will have its limitation. Again, this is a 2 weeks individual assignment. There are a lot. If you play with your shell a lot, you'll see that it can do a lot of stuff, but it cannot do everything because again, this is a 2 weeks simple individual assignment versus a multi-decades effort of thousands of system engineer. You can't really compare, unless you're a god. Then, well, good for you. But appreciate those who create the shell for us to use to build better stuff for the future. So appreciate the work that go into just building a simple shell that you use to do programming. It's quite fun. So well, this one is, that's what I'm saying is that this assignment used to be a lot harder. It's actually at one point to an extreme is that I almost, after this PA, I was thinking about dropping the class. That's how hard it was. You have to make your own parser. You have to create your own everything and make all the handling stuff. It took the parser load, took me 9 hours. It was hard, but fortunately, that's no longer the case. Thanks to Zeke, the TA from previous semester, who also did the entire grading infrastructure. That guy's a god. You can now have your cake and eat it too. So the Tokenizer class is the bread and butter of this assignment, where you have a Tokenizer class right here. It has a string input, so it will store internal convenience. So basically a Tokenizer class will tokenize a command, a command of that you type in. And then in each command, there will be commands for like right here. It's a string of commands basically, and you'll see in a bit why. It has the constructor, the destructor, the trim, and the split. These are for tokenizing the command, so don't worry too much about it. But all you really need to care about is this: is the commands. It's a string of the commands put it together. So inside the command, there will be a command for each. There will be a string command string, and then a list of quota string in command. List of quota string in command. Yes. So enter strings. So let's say you have a string, and then there's a string within the string. Then it also handles that for you. It also detects in file and out file. This is for IO redirection. And if you don't know what that is, well, we will talk about it in a bit. It's also handle command arguments. So if you have arguments, it will deal with all that. So as you can see, it built an it's also have all this function to detect this, so that you know if it has an input, an output, or is it a background. So you can see that with the infrastructure, you can just use the class instead of actually having to write a parser yourself. It makes life so much easier, so much easier. So the tokenizer class in action. So let's say you have an lsla command right here. It will print out this nicely for you. And then lsla grep command will also print it out nicely for you right here. So let's see how it breaks down in action. So this is we're going to talk about this one because this one is a little bit complicated, more complicated. But basically, tokenizer class will have lsla pipe grep command, and then it will automatically break it down into command. So lsla is one command and grep command is another command. And then arguments, again, lsla is one, and -al grep and command will be different arguments. And at this point, I want to kind of remind you is that from PA1, right? You did something like this. You have an arguments of array of string of grep command, right? So they break it down nicely for you, so you can literally just pass it. You have to do some more work, but it's pretty simple to pass all this into execvp and get the new command done for you. So I do have the demo. Oh, I think I have to delete this because else I'm going to get yelled at. I think I will delete this because this is, yes. Sorry about that. I got last semester. I did something like this, and I showed the code, and people didn't really think about it and start copying mine. It was my fault. And then I got yelled at. Tokenizer class. Any question? Any questions so far? Y'all have like any idea? This is perfectly understandable. Yes. Okay. Okay, that's good. I will look at the chat. So if you have any body language, I will see. Yep. So let's get into the stuff. Again, this is for previous semester, but you can see that for at least for first week, yeah. For the first week, first week rather, you will have to complete all this. Okay, so but there's no first week here. You can do whatever you. But you can see that all basic command, this can be done with just a single, with just parsing. Like, remember I told you, you can pass this, pass this into the argument and do execvp, which Tokenizer already did not 80% of the work for you. You got most of this grade, which is like 28 point. Look at these commands only 28 point. If you get it to, yeah, don't worry about it. But you can do this really easily. Like all this can be done easily. And in the past, it took me 9 hours to do the echo command because you have to think about the string, inner string, and all the space. So like, life is so much easier. And you have to do ls. And then for basic command, I will talk about how exactly you might be able you want to do this one. It's quite simple actually. It's not that bad, but it takes some time to think about it, and we're gonna go through and go to an example in a bit. And then cd command, it's just that you have to use a specific system call, and then you have to make sure you save everything for your save everything. So save the history of command so that you can do cd dash, but it's also pretty simple. So I will show you that. A basic command. Yes, this one I will delete. This does not make sense without the given hint because there's no given hint anymore. Yes, so after passing basic command cases, you know that your shell will gain superpower because you can open a text editor, you can shut down the entire system, and you can compile your shell within your own shell. You have a shellception overloaded. So once you can do that, test over this. Well, I don't know if you want to shut down the system, but you can. You can do all this and see if it works. Because if it works, the chances you're on a very good track. And then let's talk about background process. So I think it did background process, IO redirection, and then yes, okay, and then change directory. Okay, that's good. So background processes. So once you got through the basic process, now you might want to do background processing. What does that mean? Well, the goal is the terminal should not stall while executing the background process. We'll still do exec VP as normal, but the parent will not do wait PID on the child. We must keep track of the child PID and occasionally check if the child is done so that we can clean it up and prevent zombie process. So what does that mean? Well, if you shut up. Oh, what the heck? Okay, it take a while for it to hopefully it runs. Okay, right here. Okay, so you do sleep, right? You do sleep 5. You have to, it stalls. You have to wait for it to do this, and then it would done. But if you add an ampersand at the end, it immediately done, and you can execute the next command, and then it return a PID so that if you do sleep, if you do let's see, ls again, you see that once I do ls, it's done right here. So you can see that your code, your terminal should be able to do this. And how does it work? Well, let's go and see for yourself. CD. I have PA2 here. Oh yes, I do CD. Okay, so make. Okay, so I can do. Okay, apologize if it's too small, but it should be able to do the same thing. So if I do sleep 5, okay, we'll stall for 5 seconds. So at this point, with the basic command, you have to do wait PID, right? So normally with the standard basic command, you just exec VP, and then you do fork, and then exec VP, and then in the parent you would just do wait PID, and then it would be just fine. But in here, sleep 5, you see that it doesn't stall. And if I do ls right here, you can see that it given me back a PID right here, and it said it's killed. So you have to make sure that if you do this, that it doesn't wait. You don't wait PID there. You would just take the PID, put it into a list, a watch list, and then occasionally check for it. So that making sure that once it's done, then you do wait PID no hang. There's a specific command for that I will show you in a bit. But that's it. You have to make sure that's the case. Then you could do background process would be done. And I think this is one of them that is not tested. I don't think it's tested. So I think there's a mechanism for us to test this, but it's not tested on is it? I don't think the test is, I don't think it tests. Oops, I'm sorry if I do not. Yeah, you didn't see it. PA2 min. Yep. So I think it doesn't test for. I think it doesn't. Yep. It doesn't test for background process. Nope, it doesn't. It doesn't. Yes. So this one is not tested, but you should test it and make sure it works, because we will grade it still, but I don't know how. But I will ask Mary how exactly we're going to grade this. But yeah, don't worry about it. We can move on. Also, skip that. I need to also grade PA1. So I'll grade PA1, I think, starting today, and then I will get the result to marry tomorrow or the next 2 days. But yes, yeah, make sure you have all this, and then make sure you do background process. So how to do background process? So my solution, so you make a vector of type PID T, and then if the background process flag, so you have a flag that, remember, in the tokenizer, there's a flag right here. Yep. No, it's background, bool background right here. It's a flag right here. So you have, if you detect that if the background, if the command is background, then you, oh wait, then you flew through, instead of wait, you push the child PID to that vector. Okay, that is a global vector that you push it to, and then a function that check for completed background process occasionally, iterate through the table and check. So the command would just check through the table, do the wait PID to see if it returns true. If it works, then it kills it. It's done. My terminal. So this is a function. So my terminal checks right after the command is executed. So what that means is, if you go to, let me go to my PA2, and I think it's in shell.cpp. Yep. Ooh. You can see this for loop, I check it right here, right? So every time you execute a command, it will check for background processes, and then it would work. And then we'll just kill it. So if, you know, it will kill it the next time it's available, and then that's good. Any question about background process? Does that make sense? Yeah. Okay. Okay. You will play with it. It will make sense. It's really not bad. Also, if there's a W and no hang flag is your best friend. Search it up, what that does, and then you will see, understand why. So let's talk about IO redirection. So this is, I would say, this is the first part of the pipe command, which I will show you in a bit. But IO redirection, it's very simple actually. So let's say you have a process right here, and so a process, remember, you have 3 file, for the first 3 file descriptor of a process is very simple. It's just standard in, standard out, and standard error. Okay, that makes sense. And then when you open a file, right, it will create another file descriptor, and let's say it will open to min homework folder.txt. Then that the fourth file descriptor will point to the file itself, which is min homework folder.txt. That makes sense, right? So if you do dupe 2, right? So the goal of IO redirection is that, let's say if you want to output, instead of output to the console, you want to output to a file. Let's say you do lsal. So let me put this right here. So let's say I want to do lsal, and then I want to output to a file called a.txt. Then instead of outputting, you can see, instead of outputting into standard instead of outputting to standard IO, it would just redirect it to a.txt. So what that means? Well, if you go to, why is it so let's say if you do nano, yeah, nano a.txt, then you can see that it's output here, right? Instead of outputting it to a standard output. So that's the goal of IO redirection. And then the same thing with input. You can input it as, you can do something like let's see, cat a.txt, and input into grep. I think it's grep, right? Grep. Let's say .get, and then you input the a.txt file into it. Then it will just use this as the input for the grep command, which it requires an input, right? So that's basically the IO redirection. So in this case, you have this, right? And then what you do is, let's say you want to output a file into output something from the process into the folder. what you do is you use dup2 with the old FD right here and the new FD right here. So the old FD would be standard in, and the new FD would be the fourth file descriptor. So you would just dup2 this, it would overwrite. So this file descriptor 1, instead of pointing to standard input, it will now do into standard, it will go to point to the same as the folder. So 1 and 4 would point to the same thing. Does that make sense? Okay, 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 yeah. And then that's it. That's it. You just when you do the processes, you do dup2, and then it would show you that. So you know in your process, if you see an IO redirection, which again the class conveniently give you right here, is input has output. If it detects has input, you do dup2 on standard input. So you do dup2 on standard input with the new file descriptor. And if it has output, you do the opposite. You would just do dup2 on standard output. It's pretty simple. And then that would give you the whole IO redirection, and that should be another. Oh, also make sure you can also do this. You do standard input and then standard output. In that case, you just overwrite both the standard input and standard output. Does that make sense? Okay. Okay. Yeah. And then the last one is changing directory. So you do not fork an exec. In this case, you don't exec vp cd.dir, and it wouldn't work. And some version of cd. This must be done exclusively in the parent process. So instead of CD is present, if CD is present, we pass the args into the chdir, and then use get cw to ensure the process current is correct. So let's see. I think I showed here. Yes. So you see, I have the current path and the max path. Basically, if you go to man, I think it's get cwd. Okay. Sorry if it's a little bit too small. There you go. So you can see it's have the car and the size of the buffer right here. So again, it's the same thing for the previous. Remember the PA1 where you have to do the new channel. I just hard coded both values, and that's fine. So the current path I think is this, and then max path is just the length of the current path. So yeah, and then you just print it out, and you got this, and you get this. Let's see. Wait. Oh, what? Can't quit. Hello. Oh. And it dies. My terminal is not good enough to handle man page. Sorry about that. So that is current process. I think I showed it here. Yes, right here. So you do CD, and if you see CD, you would just do string command, and you have the dash right here, and you would do old pwd get old and get all of this, and you just change directory. It's really not bad. And then you would get it. This whole. Yep, that's it. Okay, any question? Because this is the end of our first part, path actually. Any question for me? Anything? That makes sense? Like 100%, making sure. Don't hide question, please, because I don't want to answer it at like 2 a.m. again. If you have questions, let me know, and I will try to answer. But if you don't have me, oh, make sure that this one requires size. But if you do change directory, it doesn't require a size. So there's that. Okay. Yes, dup2 just copy the file descriptors. Yes. It doesn't. If you actually let me do this here. Man dup2. Always go to man if you don't remember. So you can see right here. It said dup2. So dup system call create a copy of the file descriptor using the lowest one. after successful return, the old and new file descriptor may use interchangeably. They refer to the same thing, blah, 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 blah. Do not share descriptor. And dupe2, and I hate the way programmers name their stuff. Why they call dupe and dupe2 instead of dupe? And then, dupe more specific. Dupe2 doesn't make any sense. But dupe2 called the exact same task as dupe, but instead of using lowest numbered unused file descriptor, it uses the file descriptor specified in the new FD. So again, if you want to move from, you move from here. Let's say if you want to change std into output inputting min homework folder, you put 1 into old FD and the new file descriptor that you created to open the file folder into the new FD. And then what it does is step closing using the new effort perform out atomically. It's trying to implement. Where is it? Oh, right here. If the file descriptor new FD was previously open, it is silently closed before being reused. So what that means is if you're going to do this, right, std in will be gone. It will close std in forever. So let's say you have pipe commands, and there's some problem with that, but the way I solved it was pretty stupid, but it works. Is if you're going to do this, right, make sure you save a copy of std in. So like make sure something else is pointing to std in, or else there's no way to point to std in. That's the thing. I think you have to use copy or dupe. You use dupe first, and then you use dupe2. So dupe first will duplicate it into a different lowest to it. So you duplicate std in, so that with dupe2, when you do dupe2, it closes std in. It closes for 1, right? It kills for 1, but you can still open std in a different file descriptor, or else there's no way to open std in or std out, and that would cause a problem. But this is more for the pipe command. For the IO redirection, it's a no issue. It's fine. So there's that. Okay. So any other question? Does that make sense? So it will copy it and it will close the old one. That's the specific part. It will close the old file descriptor. I think dupe doesn't do that actually. Yes, it doesn't do that because you can see it said it after successful return, the old and the new file descriptor may be used interchangeably. So it doesn't change, it doesn't close it. But the dupe2 does. So if you use dupe2, make sure you use that. And then there's dupe3, which is dupe2, but with additional flags, so don't worry about it. Okay. Any last question before I move on to the next one? In 3, 2, 1. Okay, let's go to the next one, I guess. Okay. Oh, okay. Okay. Here's the meme for you this week because I got some inspired stuff from a Stack Overflow. But it's true. I stole some of my code. No, I did not steal anything. I took my own code and then I just use it. But yes, this is something funny is that you can literally go. Why I'm saying this? Because if you have no idea how to do pipe commands, you can literally go online, go to Stack Overflow, and then get an idea how to do it. Like it's really simple. And not simple, but it's really straightforward how you would do it. But no more question. I remind myself again, and then last week there's that. So this is the last part, which is pipe command. So what is a pipe command? So let's go in. Okay. So like FIFO command, unpiped command has 2 sides. So remember, so this is a picture I drew. Sorry for the quality. It's not the best. But you can see that it has a write only. And then so the server, if you want to communicate between the server and the client, you have FIFO control 1. So that's the first control channel, first pipe. And then this one, the server can only write to it and the client can only read from it. And then the other one will just do the opposite. Though the client can only write from it and then the server can only read from it. So So unnamed pipe will do the exact same thing. So unnamed pipe will have FD2, right? You create a file descriptor right here of a like a 2 element integer array, and then you would pipe to it. You would use the pipe right here, and then it would just pipe to the FD. That's pretty simple. One thing for me that is pretty, it's pretty unintuitive is the way they name it. So FD1 will be the right side, FD0 will be the read side. What I always think in my head is that if you write from the first file descriptor, you read from the second file descriptor, because it makes sense with the arrow, the way the arrow, right? So this is the flip, it flipped. So the way I think about it is, I remember thinking how the file descriptor FD1 equal std out equal to 1. Remember that? So that's how it's actually make more sense now that I think about it. Is that if you want std out, you do fd1, and then it will give you 1. It's the same thing with the file descriptor, and then the same thing with file descriptor to 0. So pipe process. So you have a parent std in, right? You plug it into, so you spawn 2 processes. Let's say you have pipe, right? You have LSAL, and then you have grep. Remember last time? So std in will be plugged into pa1 in, which is, this is actually wrong. This is actually my mistake. With the way it's actually should be similar like this, but what the difference is that instead of getting in from parent standard in, what I would just do is I make this the standard in, and you will see in a bit what I meant by that. But basically, you have 2 process. You have P1 and P2, and then what you do is you plug the standard in into do the processing. That one will output. You plug into the pipe command, and then that will be out right here, and plug into end of out P2, and it would output into there. Does that make sense? Okay. It takes some time to think if you're confused a bit, but you just get the input. So it just treat the output of the previous command as the input of the next command, as you can see. And the unnamed pipe is the way to communicate between the 2 commands. So it's another IPC. So there's that. And then you would just output this to the output to the parent out std out, and that worked. So this is the essence of the terminal pipe command process. This is the pipe process. So okay. Okay, so any questions this part, or anything, comment, anything? No? Okay. Okay. Let me do this. Okay. So my implementation, this is just the way I do it. You can do it whatever way you want. It's actually, there are many ways to do it. But my way, it makes life a little bit easier for me. You don't have to do this, but I make a separate function called that is called from the main when tokenizer object is greater than 1. So remember this one right here. Right here. It's very simple. So I have the tokenizer class right here, and if I do tokenizer dot commands dot size, which is just a array, I think it's a vector rather. It's less than 2, right? So if it's just a single command, then I just process the command, a basic, simple process single command with our redirection progress process Jenks directory. And then if you have a pipe process, you will have another process called pipe process. That's it. I just have that. Okay, so let me zoom. So a function that spawn processes and connect the input and output to a process correct and file descriptor. I will show you right now what that means. Right here. Okay. So that's the pipe process. And you will have to, this is my very specific way of doing it. So it might not even make sense, but that's okay. I will explain it. So you have in, out, and FD, right? So the first process should get the input from the standard in. That makes sense. So you, by default, you get the in equal to 0. Does that make sense? Okay. So now we spawn here all the pipe process. So if let's say you have this command, let's say you have this command. Why can I not quit? Hello? Oh, okay. So let's say you have ls al al. Oh, I understand. ls al grab let's grab let's say GitHub. Okay. So what it does is you can see that it should output the, if you do ls al, it output this, right? And then if you do ls al grab GitHub, what it does is it, instead of outputting here, remember, you would just use this as the input for the next command, right? So the next command, grab GitHub, grab is just a is stand for something, it stands for new, I think new regular expression p. I don't remember what p stands for, but re is regular expression. So this is just another a way to search text. So in this case, if I plug in GitHub right here, it would filter out to find all the line that with the word GitHub in it. Does that make sense? So you see, you pipe the output of the previous command as input of the next command. Makes sense. Okay. So I have a loop right here. And then I will do pipe FD. So now I have a new pipe. So you generate a new pipe right here. Okay. And then what if you do is if so you check, this is how I check if this is the last stage of the pipe. So you want, this is the last. So let's say you do LSAL like this, and you do grab git. Oh, did it work? Oh, grab git. Sorry, grab git. Okay. So you can see that now you have multiple pipe, right? So now you have ls, you get output that, you do grab and would output GitHub with this whole thing red, and then you use that as an input again, and then grab it to find just the word git, right? So this is a 3-stage pipe. So the goal of this line is to the last stage of the pipe should get its output to std out. So does that make sense? Yeah. And then you would do and this is where you need to do it yourself. I cannot show you this because this would, but I will give you ideas. So the last stage, you want to make sure that it's output to 1 and it's not output to some other thing, or else you will never see the output, right? So the last stage of the pipe should get its output to standard out. And then all other stage should just get out from the FD, should get from this output, the standard output, FD1, the right side of the pipe, right? And then it would be working. It would be work. And then you would just plug once you set up all these, right? You have the input, you have the output, you have the pipe. You would just plug it into spawn process, which just have the input IO, the output IO, and the tokenize the command that need to be executed. And then done with the right end of the pipe. Once you're done with that, the child is already wrote. The child already wrote here prevent stall by closing it. So once you you execute the process, then you need to make sure you close this so that it won't cause another stall. And then you would would be the next process. Does that kind of make sense? It takes some time to think about it. I will have a visualization after, but you would have to, all you need to do is you have to interchange out and out to make sure it's work, and then you do this. Sorry. Sorry about that. Okay, so there's that. it might be different from the way you do it in the LE2s as well. So, but the idea is there. The idea is there. Okay, let's talk about details. Oh, okay. So again, what should go inside the loop? Yeah, well, you create a pipe before plugging the value into the font. We should check whether this command is the last command or contain IO output redirection has output. If it has the last command and does not contain IO output redirection, out equal to 1. Okay. Else, plug the values from the spawn process function in the initial loop n equals 0, because it's from SD in from the parent, but it's not from the parent. It's from itself. I said the parent, but that's a lie. Once the process, a spawn process function is called, we close the right side of the pipe. Yes, so to prevent stalling, and then in FD, so then in else, and then in will call FD0, which is the pipe next command, and then you repeat the process. And then what should go inside the spawn process function? You fork the child as normal. In the child process, we check for the current command if it has input. If it has, we do dupe2 like a single command. If it doesn't, we check if the in parameter is 0, right? If the in parameter is 0, it's parent standard input. If it is not, then we do dupe2 on the child std in with the in parameter value. Which gotten from, you can remember, it's gotten from here in parameter. We do the same thing for the output of the process. It has output, out parameter. You do the same thing as this one. I assume that we do not combine pipe with background process together. So in the parent, we just do the standard wait PID to guarantee the order. So you just do wait PID for each command you spawn. I think I do it right here. Oh no, it's in there. It's in there. Let me scroll. Yeah, you can see it right there. So I just do this, which is normal. So don't do background process with this. You will be we don't assume that. That would be kind of complicated. So let's say, okay, so here's a command. Here's a command that that we're gonna do an illustration on. So let's do LSLA right here. So let's okay. Copy this whole thing. Oh, it doesn't work like that, huh? Okay. So it's LSAL, I think it's like grab command. Okay. TRAZ. Okay. So what it does is you get LSAL, okay, which is this, and then you pipe use this as an input for the next one, which is grab command. Okay. So grab command, what it does is to do ASLA and then grab command. And what it does is it's just gonna, get you all the filter out everything that all has the word command in it. And then TRAZ will transform all the lowercase into all uppercase, which you get right here. Does that make sense? Okay. Okay. So we need 2 pipes for 3 process, right? Assume pipe 1, FD0 will be 4, FD1 will be 3. And then assume pipe 2, FD0 will be 6, FD1 will be 5. And I'll show you right now. Okay, just assume like that. Okay, so LSAL, right? In would equal to 0, which is the standard input, right? Out would equal to 3, which is the standard out, the right side of the pipe, right? Because you will out here. So once this is executed, then the output will be written into the pipe, right? And then command is LSAL. Okay. And then, okay, so then you would call the function again, the next call. Well, now in would be equal to 4, which is this case right here, which is the value written last time. So 4 will be the read side of the pipe, right? and that would be plugged into the in of the grep command. And then the out would be here, right here. So that means, you know, it would then write into the next pipe, right? And the grep command, if it's a little bit too small. Okay. And then it would wait for the next one. So now it will stall again. Okay. Okay. So the last one, 6 would be the input of TRAZAZ. The commander is right here. And then in would be the 6, right? Because you're reading from the previous command, right? You're reading it from the previous command. And then out would just out to standard output. Right? So if it's okay if you don't understand it, immediately draw out on paper, think about it, then it will eventually click eventually. It took me a while to understand this. So it's okay. And I think that's it. Once you've done this, you're done with the PA. It's really it. So it's so you can definitely finish a lot of it in like a day, for sure. You can finish a lot of it in a day. So yes. So any questions for me? And then next week, thread, blah 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 blah. Nah, this is not true. We won't do PA3 until way after the midterm. So don't worry about this. But yeah. So any question? Please ask. This is very, very so. If you have any question, please ask. Does that make sense now with LE2? Does that make sense with LE2 now? Moon? Is it? Sorry if you. I butchered your name. Is it Moon? Is it MU? Sorry. Anyway.
Yeah, I think we're good.
Yeah. Does that make sense to you? With the pipe command now, what it does?
Yeah.
Okay. Okay. All right. So I will. That's it. Well, I will see. Well, I will see you in the recording next. I will see y'all in the recording next week. So have fun. Actually, I will keep it on because maybe. No, actually, I won't. Stop.